Hello everybody, and welcome to this new stream. It's actually the second episode from our try to make a social media network application from scratch, implementing or following domain-driven design principles and patterns, which is a fairly big endeavor, I would say. Last time out, we just talked about the domain-driven design principles and patterns and the core concepts, because I thought it would be necessary before going into the real coding or only coding part. I thought it would be necessary to just look a little bit into what actually domain-driven design is, what are the core principles, and basically our target. So a certain way that we want to write our code. And first we need to know that. So if you didn't follow that stream, it is recorded and you can find it both on Twitch. If you go to the videos on my channel, you will find there a section which is the social media network, and there you can follow the first episode. But of course, it would be better for you to do this after this stream. Also, if you go to YouTube, I have also a channel there. It's called Code Wrinkles. I just posted in the chat. And if you go there, you will also find a playlist which contains this social media network from scratch using domain-driven design. And you can check the recording there. Basically, all the recordings, all the streams that I make will also be posted there on YouTube. So yeah, please just feel free to go there and check it out. So let's get started. And I said the last time that what we want to do right now is to actually start writing code, which is actually correct. This is what I want to do today for the most part of the stream. But as you see right now, basically we are in Visual Studio with a very blank repository actually, because by the way, I will push all the changes that we make, I will push them to GitHub. And there is a repository which is called Twitch UniConnect. And if you scroll down on the Twitch channel, you will find a panel which contains Git repositories, and then you'll be able to navigate from Twitch directly to this GitHub repository. So I plan that right after I finish this episode, I will commit and push all the changes to GitHub, and then you can clone the repository and of course take it from there. And probably from the next time out, I guess I will create a new branch for each episode, because in this way we all have a way, including me, to see like the progress that we did with this application. Because I guess it will be something that we will be coding for a very, very long time from now, which is for me very exciting. But before we actually get started with the code, I still wanted to briefly look into a theoretical point, and this has to do with the way that we want to organize our solution and projects and so on in Visual Studio. So let's first take a look at it. And it's about microservices actually. Why? Because usually when we talk about domain-driven design, or usually in most of discussions about domain-driven design, it's always put in connection in relation with microservices. And the reason why this is the case is because basically we saw that in domain-driven design we have bounded contexts. And usually the best way to architect a microservices application is to create a microservice for each bounded context. And that's why usually domain-driven design is related to microservices. But however, the idea is that you can still use domain-driven design even if you're not working on a microservices project. And I would give an example of a desktop application. For instance, workforce management desktop application, which would be a very, very complex one. You could fully go for domain-driven design there. But in that case, you would probably not have that application based on microservices and doing a lot of HTTP calls to get the data and so on. And depending on the scenario that we want to implement, or the idea if we go for microservices or if we don't go for microservices, then we could choose a different way to organize our Visual Studio solution. And that's why I wanted to take a look into this idea of microservices, where we have each or one microservices per bounded context, And this is, for instance, a reference architecture of an application built with microservices. And you see here that we have different modules of the application, like vehicle management, customer management, auditing, notifications, and so on. And of course, we have a message broker. I won't go deeper into the idea of microservices right now, but I just wanted to point out that in this case, so if you want to create this application that implements this type of microservice architecture and also use domain-driven design, we would probably organize our Visual Studio solution according to these different modules that we have in this application. But on the other hand, if we don't use a microservices approach, then we would probably organize our folders maybe a little bit different. And the way I think that we'll be doing for this application is something that would be, I would say, a combination of both these approaches. Why? Because actually the plan is, or when you start to build up an application, if I would start right now, if I would plan to really build this type of application and make it a product, of course, at the beginning, it doesn't really make sense to have it as a microservices, because it will incur a lot of costs. But I can assume, or I can think that probably in a few years or maybe months, my application will grow very, very fast, and then it will arrive a point where we would basically have to take into consideration the idea of refactoring this application into the microservices approach. So that's why when I start to organize the code for this application, I would kind of take this into consideration with the aim that at the end, what I want to achieve is basically that when I'm at a point where I want to refactor this application into a microservices one, what I want to do is I want to make this very, very easy. So this transition should be very, very easy. From my point of view, and that's why when we'll organize our solution, and we'll start right now, we'll take into consideration this type of approach. And by the way, as I said, I'm building this application right now from scratch, so I don't have all the ideas exactly in mind of what do we want to do, what do we need to create. I basically know where we're starting. But I guess that this application would also grow organically, hopefully, or I hope at least, based also on ideas or feedback that comes during the streams via the chat. So that's why please feel free to jump in the chat and say hi, or add anything, or ask questions if you want to look at a certain class or at a certain code part. Don't be shy. Just please interact with me, because to be honest, this type of stream would be a great learning opportunity, both for me and I guess also both for you. So if you have ideas that are probably better than mine, then just shoot them in the chat, and we'll see how we can implement your ideas. Okay, so let's get started. First of all, we need to create a new solution, because we don't have a solution so far. So I would go to team here, and yeah, let's it's solution explorer. I would like to go on file, new project. But what I usually like to do here is I don't really want to create a project right now. I just want to create a blank solution, and I guess you don't see my screen right now, but I guess this, yeah, that right now you can see it. Okay, so I would like to create a blank solution right now, because I want to add afterwards my projects to it. So I just want to start from scratch and don't have any default project in the solution. And I will name my solution, in this case, Twitch. Let's make without dashes, UniConnect. Hopefully I typed it correctly, and then create. So this would create a solution for me, and now the solution is there, and basically we can start working with that. Now the idea behind this, or what I like to do when I start to organize my solution, is to use solution folders. And the way I would prefer to do that is basically to use a solution folder to define exactly what module of the application we have there. And in that case, I would like to start from scratch, and I would add a new solution folder. And the first thing that I can think of is what we'll have in a social media application or a social media network. It would be a social module, which will contain basically the ability to post messages there, to have a news feed, whatever, this type of stuff, like we know from Facebook. Also, the idea of the social media network that we want to create is that it should be a social media network aimed for a university, which means that it would most probably also need some features that are very specific to this idea of a school or to a university. And in this case, we will probably also have a module that would handle the schedules, because in such a social network, teachers might need to be able to create schedules, and students might need to be able to check their schedule so that they know exactly where they have to attend their classes. So in this case, we would also have a new solution folder, and this solution folder would be called schedule. And here we will have the schedule module. So basically what we have here in each of these folders, we have a separate bounded context. Another feature that I think we might have, I would guess right from the start in one way or another, would be a gradebook. This is a type of application where teachers might need to be able to use a gradebook to maybe track presence, maybe to write down the exam results and so on. And then in this case, I would create a new folder which would be gradebook. And right now, I don't think, or I'm not sure exactly what other features, what other modules will be there in my application, but of course we'll be able to elaborate that at a certain point. But what I would like to do further is that, okay, besides this bounded context, since my application won't actually run in a microservices environment, so this means that I won't have an API for each microservice. And in that case, I would also need an application layer, and I would say here add new solution folder, and I will call it application layer, so that that will basically handle all our stuff that would make our domain model ready, let's say, to display in a web app. But then again, what we also need to have is probably the front end part. And probably in the front end, we'll have at a certain point, I'm not sure if we'll be able to implement it during this stream, but who knows, or during the entire stream series, but yeah, who knows. We would have then a different front end. So I would add a new solution folder, which I would call front ends. And here in front ends, I would add some subfolders, another solution folder, which I will call right now. So one would be web, because we would have probably a web application at a certain point, and we will probably also have a mobile application at a certain point. So let's create this mobile. Okay. And the next thing that I would think that I would need to add from the perspective of how I want to organize my code and projects and files is that I would need to be able, as discussed in the previous episode, there are some concerns, I would say, some infrastructure concerns, and not only, that are kind of common for all the bounded contexts that we will have. So in this case, what I would like to do is also create this shared kernel. We told last time that usually when we talk about domain-driven design, this type of layer is called the shared kernel. It can be also called common or things similar to that. But I like to call it a shared kernel to be fully compliant with the terminology of domain-driven design. So I would add another solution folder, which would be shared kernel. and that would be it. So right now, I guess that from the point of view of how I want to organize my solutions, I guess that I have everything that I need. If you have other ideas, then please feel free to jump in the chat and basically let me know what your proposals are, or if you have questions, don't be shy and ask them in the chat. So let's go then one step further, and of course right now we would have to create some projects, I guess. And let's maybe start with the social one. And here in social, what I would guess we would have is we would have first a project for the domain, and we will then have a project for unit tests. And let me start them. So we go here into this social folder, and let's create a new project. And this project will be a class library, of course, because yeah, that's what we need to create. Basically everything will be a class library in the solution, except for the front ends, and except for the unit test project that we will see just a little bit later. So in this case, I would choose this class library in .NET Standard, and I would name this project. Let's name it Twitch UniConnect dash social and dash domain. Why I like to also use this domain because in this project we will implement the domain for this social bounded context, which means that here we will implement our aggregates, our domain services that are specific for this bounded context, and so on. And just a few seconds until this solution creates. Of course, we have this this class that we will delete because we really won't need it right now. And okay, the next thing that I would like to create is another project in the same solution folder. And this project, let me add new project. This project will be for unit tests, and for unit tests we would need to create a console application. For unit tests, I like to use NUnit as a framework and library. And NUnit requires us that we have a console app project for unit tests. So I chose a console app next, and here I will name UniConnect, Twitch UniConnect, sorry, .social, because we are in the social bounded context, and I would name this unit tests to make clear that these are unit tests, and then we click create. Right now we won't create any tests right now, so we just we'll jump over this project right now. But I want to lay out a certain structure of this project. So the next thing that we would need here, just to have an idea about the layout of the application, is another project. And this project would be once again a class library, and this time this will be for the DAL layer, for the data access layer for this bounded context. And we'll see later when we'll implement Entity Framework Core, probably. I'm not really sure yet that we will use Entity Framework Core or something else, but the idea is that if you use Entity Framework Core, basically the best practice is that for each bounded context you should have a separate DB context, and that of course brings some complexity to the entire setup, but we'll talk about that when we'll implement our database layer. So right now I would have to also give a name to this project, and this would be then Twitch UniConnect. Okay, social, because it's still the social, and then it would be DAL because this would be the data access layer. And then let's click create. And yeah, that's it. We have right now another project. Good. Before we really start to write our code, I won't go and create some projects in all the folders right now. I just wanted to have kind of like a starting point and set a certain layout to know, for instance, that when I go to other bounded contexts like schedule, to not miss or to be consistent. I just want to have a reference here in the social about each or about the number of projects that we need for this social for that certain bounded context. So I would take this social bounded context as a reference when I will create projects for the other bounded contexts. But actually, before we can go ahead and start coding the base classes or our first entities and value objects, what we need to do is to create our shared kernel. And this is very, very important, because this is, for instance, the part or the layer of the application where our base classes will go, and we'll see that the base classes are very, very important, and we'll start to build them. It would be, I guess, very, very, very fun. So let's build up the shared kernel. So in the shared kernel, I would need a project. Let's click a new project, and I would need a class library, and this would be twitch.uniconnect shared kernel. And let's click create. And for the shared kernel, of course, we won't need any data access, but we would most probably need unit tests. So let's create also a new project in the same folder in the shared kernel, and add new project. And this project would be then for unit tests. Once again, this would be a console application, because NUnit requires it to be a console application, and this would be then called Twitch uniconnect shared kernel unit tests. Okay, I think it's correct. Okay, let's click create. And then also this project will create right now. Once again, we won't write some unit tests right away, but we will start writing our classes here in this shared kernel. And let's delete this default class, because we don't need it anymore, so it's not important. By the way, for those of you who have joined a little bit later, just drop by in the chat, say hello, and whenever you have questions or whenever you want to add something, or when you see that I get stuck at some point and you have ideas on how to continue, then just please feel free to jump in the chat. I would also say hi to each of you, and I'm constantly also looking at the chat. Okay, so now I guess we can already start planning and start writing our code, I guess. So yeah, let's sorry, one just second. Okay, good. So first of all, in the shared kernel, what we want to place are the base classes that we would need. And the very cool thing about domain-driven design, or about this approach, is that what we'll have to do is basically write our own base types, which is fairly cool, I guess. The first time that I really got into this, it was a really nice challenge for me to think about, okay, what does my base class actually need? Because it's not really straightforward, and it of course also depends a lot of the functionality that you want to put in that base class. And if you ask yourself why I think we should create some base classes, and when I say base classes, I really mean base classes. So for our application, these classes would be something like the string in .NET. So it would be really something that we'll use throughout the application to enforce a certain way of writing code. So the first thing we will have to do here is create a new folder, and I would like to have here a folder that it would be called types. once again, whenever you have ideas or feedback, or you want to do something different than I do, then please just feel free to jump in, write me something, and I'll surely try to see if we can do it your way. So when it comes to base classes in domain-driven design, we actually have two base classes that we really have to implement. So this is really the starting point for each project in domain-driven design. And those classes would be, of course, entity and value object, because as said, these are the classes that sorry for these themes. I thought it was, sorry, just 1 second, let me change a little bit. Sorry for that. I thought I closed my Microsoft Teams, but it seems that no, I didn't. Right now I guess it should be closed. Okay, I see also Skype is open, so let's close it also to not be bothered at all. And yeah, it should be okay right now. Okay, so yeah, let's go back. Sorry for this short interruption. Again, what we want to create right now is or are the base classes for entities and value objects. And let's start with entity. And of course, to do that, we'll simply create here a new class that we will call entity. And this entity class, of course, it will be a base class. So it will be used throughout the application in a very specific and certain way. So this is why we have to put a lot of thought on how we want to implement it. And I think that first of all, or the first thing that we should think about is that, of course, this class should be public and it should be abstract. So it should be an abstract class. We won't be able to create directly instances of this class, but this class needs to be inherited by all entities throughout our entire domain. So it would be an abstract class. Now, when we start to write our code, I would like also to create a constructor. Let's make a protected constructor so that only classes that inherit this entity class are able to do something with it. And for now, let's leave it blank. Now, if I think further just a little bit, what I want to do here with my entities is also to enforce in a certain way what identifiers we will use. And I think the most common type of identifiers are ints, because usually from right when you start to write your first applications, you mostly work with ints. And if you work with entity framework core and entity framework, the normal framework take care of how IDs are generated when you want to persist objects in the database and so on. But IDs, well, they are good, but in recent times I come to a certain conclusion that I certainly prefer to use GUIDs, guides. Why? Because often you would be or it would be needed that you want to do some cryptography maybe on IDs or with the help of the ID. And using GUIDs in this case would be very, very helpful, because as the GUID well has a very specific length and a specific way to be constructed, it's easier to be used, for instance, if you want to use it as a key to encrypt something like, for instance, password. Not that we will really encrypt password using the ID as the key, but I just wanted you to give an example. It would be much easier with GUIDs to manage this type of aspects. At least that was my experience. So this is why I like right now to mostly work with the GUIDs when it comes to identifiers. So what this means, it means that I want to enforce a certain type of ID here. So I would make this also generic, and I would say that each entity would be an entity of a TID. Now, of course, what type this TID would be is something that we will maybe think about just a little bit later. But the first thing that that we would have on this class, or the first property that I would see on this class, is of course this public. It will be of type TID, and it will be called ID. And here is the first very important thing that I learned when I started to work on a project with domain-driven design, is this whole idea of encapsulation. And I might have been very stupid, but I really didn't get the whole idea about encapsulation and abstraction until I started to study and learn and implement these domain-driven design principles. And you'll see that what we'll do basically throughout the entire code base, we'll never, or almost never, we won't have public setters, because the whole idea about setting properties should be a concern of the class itself, because the class, at least in domain-driven design, should be also considered as a container of state, and therefore the class should be responsible to handle or to make sure that that object that is instantiated from the class will always keep will always be in a consistent and valid state. So that's why it's important to really encapsulate all the logic and to take control of everything that changes. And if changes come that would bring our object or would put it in an inconsistent state, then of course we can throw errors, or we can send notifications, whatever. But this is why I will always use private setters here in this stream, or almost always use private setters. So yeah, and right now, of course, in the constructor we can see that okay, I want the ID to be of course we need to have this also as an input here, as an input parameter to the constructor. So it would be TID TID. Okay, so yeah, this is the very basic constructor that we will have here. Now for entities, actually there is not really much that we need to do. Another thing that I like to do always in code is use region, and this region would be maybe we'll have several constructors at the same time at a certain point. So it would be constructors and properties, and here I would end the region. And then I would have a region, I guess for public methods and so on. But right now, I won't think about public methods on this entity base class. But one thing that should be enforced in my entity base class is of course equality. I will need to implement equality here. Why? Because we might be tempted to take or to use the object.equals method to check for equality. However, the problem with that method is that it always returns reference equality. Reference equality means that it's basically if the reference of that reference type is the same, then they would be considered equal. And that might not be wrong in our case, but the problem here is, or if we want to adhere to domain-driven design principles, one thing is that we would need for entities, we would need identifier equality. So we would need to implement equality based on the identifier and therefore override, I would say, the behavior of object equals. And to do that, what I would propose to do, but once again, if you have better ideas, then just let me know. I would simply want to implement IEquatable, and here let's make it IEquatable, and it would be an IEquatable of entity of TID. And of course we would have to implement this interface, and that would generate, let's implement interface like this. So implementing at least the IEquatable interface means that we simply need to add this method, like a public method that is called equals, that returns a bool, and that implements the logic based on which, well, you want to implement equality. However, when implementing equality, there are some other things that might be that we might need to take into consideration. For before we do that, let's make a separate region for that, which would be, I don't know how to call it, equatable implementation. Okay, and something is still not right here. Okay, what do I miss? This is the namespace, this is the class. What's this error? End region directive. Okay. Okay, because yeah, sorry for that. So we need an end region here, and now everything is fine. Okay, so what we can do, seeing that we will have this identifier always be of type GUID and or of type integer, because we still want to give that opportunity. Implementing this this method is not something very complicated, I guess. So again, if it would be string, then it would be maybe a little bit more complicated, or well, we would have to think about more scenarios when implementing equality, or when thinking about what means that two objects are equal in our case. But in this case, since we'll have either numeric type or GUID, we can use the get hashcode method, and simply we can say that, okay, if the hashcode of the ID equals other get hashcode, other.id, sorry, get hashcode. So in this case, I guess that yeah, that would actually mean that we have equality. Now, however, when we want to implement equality, there are, as I said, some other things that we might need to take into consideration. And the first one is that whenever you implement equatable, it's also desired that you override the object.equals method to use basically your equality check and not the default check for reference. So that's why we will also implement that. It would be a public, it would be an override. I think it should be bool, and it would be equal. But in this case, yeah, it is the object. And what we need to do here is, well, actually something very, very simple. It's we just need to say, okay, we return equals, so our method, and we want, of course, to in order to check the equality, what we need to do is we need to cast the object to an entity of TID. So we will do this by object as entity of TID. So in this case, our override of this object dot equals would then implement or fall back to our implementation of equality, and this would make sure that that we always have the same equality check, no matter how we perform that. However, once again, with best practices about implementing equality, I'm just sure here, entity of TID overrides. Okay. Right now, what I would like to do is, as said, as a recommendation or best practices, that whenever you implement equality and override also the object.equals method, you should also override the get hashcode method. So in this case, we would have here a public override. It would be int get hashcode, and getting the hashcode in this case, it's very, very simple. Instead of having base get hashcode, we will have get ID. because we just want to get the hash code of the ID. The ID is the only thing that that really is important for us. And then, as a further best practice, when we implement equality, I guess, is to also implement or to overload or to override the operators. So that would be equal, the equal operator and the not equal operator. So let me also do that. It would be public static bool operator equals, and here I would have an let me scroll down. I would have an entity of TID on the left hand side, so left hand side, and I would have an entity of TID on the right hand side. And then implementing this would be actually very easy, because I just have to use my implementation of equal. So I would simply return the left hand side equals right hand side, and that would be it. Now the only problem, or why I have here an error, is that when of course we override this equals operator, we also do the same thing for the not equal operator. So in this case we would have public static bool operator, sorry, not equal. Here we will have again the same thing. Okay, entity of TID left hand side and the entity of TID right hand side. And implementing the not equal operator is actually very simple, because we just have to negate this equals operator. So I would say then not equals, and I would say here left hand side equals right hand side, and of course semicolon at the end, and that should pretty much do it. Now I have implemented equality, which is already, I think, a very good thing. However, one other I guess for now it would be the last thing that I would like to do for this entity based class is, as I said, I want to enforce some way that this TID is either of type GUID or integer. Now, as we don't have this option to put it here directly, like it inherits from numeric type and GUID, so we cannot define it like that. I would probably prefer to create a private method that would check if the ID is of a certain type. So but that would be in a different region. So let me create a new region. Here it would be private methods and region, and it would be simply let's make, okay, private, not public, and it should only return bool is valid ID, and we need the TID as an input parameter. And what we will do here is simply return ID, but of course I don't have to make typos, so return ID is int, or where is the pipe here on my keyboard, or ID, maybe we'll have it also long, but I guess it's not good to have such big IDs because they require a lot of space. So let's restrict this right now to int and GUID. So I would say that here we simply return if, of course we need here to also is. Okay, so if the ID is an integer or if the ID is a GUID, then we return false. If it's totally different, so neither an int, neither a GUID, then we will return false. And yeah, that's basically it. Of course, what we will do right now, later, or probably when we are at a later stage of this application, we'll also implementing some proper exception handling. But for now, what we'll do here is we'll simply have here an if check, and we'll see that well, if how did I call my method? I forgot already how I call my isValidID, or isID valid, I should have called it, whatever. isValidID. So if it returns false, this valid ID, then for now I would throw new, let's make it argument exception, and that's it for now. Okay, what does it say? Okay, of course we have to pass in the ID, of course. Yeah, so I guess that that would make it. So in this case, if somebody well tries to or if me as a developer or some other developer that might work on this at a certain point would say, let's create an entity, and it will inherit this entity, but it will provide, I don't know, a double here as an identifier, he won't be able to do that at all. So I guess that's the behavior that I want right now. So let me check if there are any other questions. So I don't see any questions so far. I see we have some more viewers now, so hello to everybody. I hope you enjoyed. If you're not following me, and if you want to always know when I go live, then just follow me. I think that would be the best way to keep track of when we are doing our episodes. Okay, so now that we have the identifier ready, I guess we can go to the next step. And now that we have the entity base class ready, we can go one step further, I guess, and go over to this entire concept of value object. And the idea of value object, I think it will be or is for sure a little bit more complex than the entity when it comes to defining a base class. So what I would like to do right now is what's the time? Okay, let's go here in the types folder, and we add a new class, and this class will be called value object. Now this class would also be abstract, and here what we really need to do here, I think in the constructor we don't want to do anything. I don't see, at least for now, the point to make this value object class generic. It's simply a base type, I would say, that other classes might implement via inheritance. So one thing that I guess would be very, very important would be to implement iEquatable, of course, because we need a way to check if two value objects are the same, and it would be the interface iEquatable of value object. So right now we'll start off by doing exactly the same things that we did earlier. Implement interface, so we will implement equality. The only thing, however, is that for value objects, implementing equality is way more difficult. Why? Because what we need to do is find a way through which we can define which are the properties for each value objects that need to be taken into consideration when we perform this equality check. Because, for instance, let's assume we have a value object class that is called name. That, of course, should represent a name. And in this class, we would have properties like first name and last name. But we might also have initials. So the problem here is that what we want to do in value objects is enforce attribute or property equality. Once again, reference equality is not okay for us, because we could still have two different instances of the same value object, but as long as their values or their properties are the same, for us it is exactly the same thing. And if you want to understand better how value objects are supposed to work and didn't follow my first stream, my first episode, then you can go either to the Twitch channel on videos. You will see there the first episode, or you can go on YouTube and search for this channel, Code Wrinkles, which is also my channel, and all the recordings all the recorded streams that I make here, I will also upload them to YouTube. So you can also check them there. A subscribe also to YouTube would be very, very highly appreciated. And also, of course, a follow on Twitch if you don't follow me already. So yeah, let's get now just a little bit further. So when we said, when we want to implement equality, we have to take into consideration these properties. However, let's also assume that our name class might have also a property which is called initials. Now, for instance, when we do the equality check, we don't want to also take the initials into consideration. And why is this important? Because the first thing that I would think to do when implementing a property equality or attribute equality is that I would simply use reflection and read into the fields of that object, and then simply check each of the properties. If they are equal, then at the end the entire object is equal. But that wouldn't work in this scenario where, well, we have properties that we actually don't want to have in the equality check. So in this case, we have to find an alternative way, and one alternative way that I have seen in different places, and I think that it's fairly okay. It's also implement a protected abstract method, which I guess, of course, I have to also type it correctly, which will return an enumerable of object, because we don't know exactly what, or we want to apply this to all types, and let's call this method get atomic values. And we don't need to implement it since it's an abstract method. However, the idea is that each class that inherits value object will need to implement this get atomic values, and there in the value objects with yield return, we can simply define all the properties that we want to have for this equality check. So in this case, we can right now, I guess we can assume, or even be sure, then that whenever we have a new value object, it will have this get atomic values method implemented. So in that case, that object will define exactly, hey, this is the set of properties that I would like to have taken into consideration well when we want to check for equality. So in this case, we can start to implement what equality means for our value objects. And in this case, first of all, let's it's fairly standard. If other equals, sorry, it's not JavaScript, so it's not 3x equal. So if other is null, or if other get type is not equal to get type on the current object. So what this actually means is that, well, of course, in order to have a valid equality check, value objects should be of the same type. So this is why we have this here. So in this case, what we'll do, we'll simply return false. In this case, it's clearly that our objects are not equal. And now the way that I think I can do, or the way that we can proceed, I guess, is first use this, or get the enumerator for these atomic values from each value objects that we want to compare, and we will then maybe use a loop and go through each to each next step of the of the enumerator, and then check if the specified properties are equal or not. So I would have then an enumerable of object, and sorry, object. Okay, it would be these values, and this would hold the values of the current objects from which we run the equality. So it would be the instance of this specific value object from which we call this method. So it would be simply get atomic values and get enumerator. Okay, and then we would have also what is not okay. What cannot simply convert type system collection generic number of object. Okay, so I might be missing something. So it would be get atomic values, this one, and then get enumerator. That is so here we return enumerable of object. So I would expect that we have an enumerable of object. This would be okay. Okay, let's think about it. Can I pick a type enumerator of object enumerable? Okay, so it says that one, it returns the sorry, of course we here we don't get the enumerable, we want to get the enumerator. How dumb am I? Enumerator, because this is really here we get an enumerable of objects, but right now we just want to return the enumerator for those objects. Yeah. Okay, and it would be other values, and we would do the same thing for the other object. So that one that is passed in as an input parameter, so it would be again get atomic values and get enumerator. Okay, and that should do it. Okay, so let's go one step further. Now when we have this these two different enumerators, we can simply try to do this, I guess. While, let's first write this, and I say while these values, the enumerator has this move next method that returns true, and if there is a further object in that enumeration, and we can also, and it returns true, but also it outs the object itself. And then we can also need to check, of course, and the same thing should be valid also for other values. So as long as we have values in these two different enumerations, then we will stay in this while loop, I guess. And now we will have to do different checks here, maybe to make things a little bit more interesting here. As we are working with value objects and identity doesn't concern us at all, what we can do here is well, simply say the following. So if let's use reference equals. So if both objects have the same reference, they point to the same location in memory, then of course we can check for reference equality, and it would be these values dot current. So what is the current item in the enumerator? is and null, so it will check if basically those are equal or null, and it will return true or false, which is what we actually need. And what we can do here is use the exclusive OR operator and check the same thing, reference equality for other values dot current and null. So if we have this type of scenario, then what we will need to do is, well, return false. So what do we actually do here? So let's first take a look. Reference equals is determines whether the specified object instance are the same instance, and it returns true if object A is the same instance as object B, or if both are null, otherwise false. So what this means is basically that if the current is null, so the current let's say object or item in this enumeration is null, then it will simply return false. And here we put an exclusive OR because we want to have here a total exclusivity. So we don't want to return true if for instance maybe both are null, because that is a case that we will handle just a little bit later. And actually what we can do next is we can say if this values dot current not equal null. How do we do that? We can also say here that and not equal this values dot current equals other value dot current. In this case we also can return false. So what do we actually do here? So in this case we don't check necessarily for the reference equality. In this case we check if the current is null or not, and we have to make sure that the current in these values and other values is not null, because if one of them is null and one of them is not, so if the current value in these values is null and the current value here in current is something else, then of course they are not equal. And then of course what we can do here is simply otherwise. So if these scenarios, or if we pass both of these if statements and nothing happens, then we see, or we can already check that okay, neither of the values are null. And in this case I could simply return, and here I would say this values dot move next, and where is the end, other values dot move next. And this return will make sure that but sorry, this return is not something that we'll put in the while statement, of course, because we would have then probably an infinite loop. So of course not, but when we are outside of this while. Yeah, so in the end, if we pass both of the checks that we have here, and we simply move next, it means that we never were in a certain scenario where the evaluated properties were not equal. And in this case, of course, we can simply return the move next. And why we negate that is because, well, when both move next return false, then we have to negate it to return true and to exit this and to return true as a value, because it means that we are at the end of the enumeration. And well, it seems that we never had to return false, and this means that in the end we can simply say that these objects were equal. Let's see if there are any questions. No, there aren't any questions. Right now, the next thing that we would have to do, as said, let's add some regions here, because and here would be equatable implementation, and that would end for now after this equals end region. Okay. So, and as previously, as we did previously for entity, if we use or if we implement IEquatable, so this public bool equals method, it is also a best practice to override the object dot equals. So in this case, we would have public override bool equals, and here equality, what we'll say is that okay, first of all, let's make an if we have a reference equality or null, reference equals, and we say here this and null. So if the object, sorry, this and object. So this means that, so why we do this check is for the case, what if both are null? Right now we're overwriting the object dot equals. So what if we compare null to null? And here, well, the answer would be then, or well, we could discuss it a lot, but if both are null, what I would like to do is maybe to return true. So I would say that if both are null equals null, I would say that it is true. Sorry, with return. However, if you think that we shouldn't return true if both are null, then we simply can return false here. And otherwise, so if they are not both null, then what we would do here is simply return, and we will return our equals method, and we'll have our object as value object, and that would return equals. Then of course, one other thing that we would have to said is implement get hashcode. So this would be a public override int get hashcode. And here when we implement this get hashcode, well, here it's a little bit more complicated, I guess. It's a little bit more complicated as we did for identity. But what we can do here is also use this get atomic values. So to go through all the values that we take into consideration for equality. And since this will return an IEnumerable, we can use the power of link. And we can simply say here select. We can do a select. And here we say, okay, we want to select x, and if x not equals null, then we return x dot get hashcode, so the hashcode of x. But if it is null, then we will return a default of 0. And we can also chain this to an aggregation method on link, and we can have aggregate, and the aggregate, sorry, that should be okay. Here aggregation methods in link are very, very cool, I guess, and we have here an x and y, and I will briefly shortly explain why x and y. And we simply want to return, in this case, x to the power of y. And yeah, that should be that should do it. So what this aggregate does, I'm not sure. Do you want me to explain this, or do you think that it's okay? So just let me know, please. Do you want me to explain what this aggregate method does on link, or should we simply go further? So just please let me know in the chat. I'll leave it for, I guess, 10 more seconds. And well, if nobody says anything, then I guess everybody knows how this aggregate method works, and then it doesn't make sense to really stick with it. Okay, so yeah, it seems that yeah. Okay, in this case we will simply go over it, and the next thing I said as a best practice would be to implement the operators. So let me try to implement the operators in this case. The implementation of the operators will be a little bit more easy. It will be public static bool operator, and the first one that we would implement is equals, and we'll have value object left and value object right, and let's implement equality here. First of all, what we can also do here in this equals is we can say if reference equals once again left and null, something similar to what we did previously. So if we can do these checks already here, it really doesn't make sense to call our equals method once more. So we can do exactly the same type of logic with XOR or exclusive OR, and you know, if reference equals, and in this case we take right and null. Of course, I have to use a comma in that case. So if this happens, then we simply can return false, because we know that those two are not equal. But what we can do otherwise is simply return, here in this case, reference equals, and let's take once again left and null, or we can simply implement then left equals right. So let me just briefly go a little bit through it. Once again, we have this if reference equals, and that will return true if both of them are null, or if both of them are the same instance, right? We compare them to null. So in our case, it would return true only if one of those is null and the other is not. That's why we have this exclusive OR. So it won't return true if both of them are null. If both of them are null, so both left and right, what it will do, it will go further here, and that in this case we can simply return left and null. In this case we already know that left might be null, and if it is null we will compare null to null and it will return true, which is the way that we want it. But if left is not null, then we will simply do left equals right. So exactly what we have implemented in the equals method. And then we have public static bool operator not equals, and here also we have value object left, value object right, and the not equal implementation is very easy because we can simply negate the equals, and here basically we say left equals right. Yeah, so I guess that would be it. So right now, from my point of view, I think we have everything that we need for our value object base class. So once again, what we want to enforce on this base class right now is that it would implement IEquatable, that we define a way that we can check equality in a way that each object would be able or is obliged to define what properties should be taken into consideration by implementing this get atomic values method, and then we simply implement equality, and that's it. I don't think right now that we need anything else on the value object base class. So if you have another idea, if you want to add something else on this value object base class, then just let me know. Maybe or probably is it's a good idea, but right now I really don't have. I don't think that we need to implement something else here. Right now, I would like to take a short break, I guess around 5 minutes, and then we'll be back. And what I want to do is I would like to start implementing some entities, and we'll switch over to the social domain project, where we'll start to build our user class, which would be, I would say, the first brick in our social media network that we want to create from scratch. So we'll go on a short break right now. As said, we'll be back soon. So I'm back, guys. How are you holding up? Everything's okay? Are you still there? Still watching? How do you find what we did so far? Was it something new for you? Was it interesting? Do you have any ideas? Please join the discussion and write in the chat whatever you think about what we did so far. Do we maybe need to add some other features right now to our base classes? So to our value object based class, and okay, always useful to find out new details. Thank you very much, Daniel. Okay, so let's go further, and I guess then now it will get a little bit more interesting, because we'd finally get to implement an entity, and when we're implementing this entity, we'll see that we will also stumble upon a value object, and we'll also stumble upon some other things like enumerations, and how do we handle them, because using enums is probably, or from my point of view, not always the best case, and especially in the domain driven design perspective, there might be some other best practices. Okay, so in this case, we'll go right now to our social bounded context, and we'll go to the domain where we'll want to start to build up our entity. And the first entity that will implement, of course, is the user. But before we go there, what I want to do is organize a little bit this domain project, and I would add a folder first, and this folder would be called aggregates, because here is where we will put all our aggregates, and we will have different aggregates roots, and in this case we would have the user aggregate that would hold all the classes that we need for a user. And right now what we can do is simply create a new class, and this class would be then we'll call it user. Let's call it user, and it would be a public class that would, of course, it's an entity. This would be an entity because each user should be identified by its ID. Theoretically, two users could have really the exact same properties, but they would still be the same. So it would be entity of GUID. Of course, we would have to add the reference to this shared kernel project, and then everything should be fine, I guess. And one other thing that we usually do is that we can use some marker interfaces to mark which is actually the aggregate root in a certain aggregate. And the way we do this, we'll go just for a second back to this shared kernel. We'll add here a new folder, and this folder we'll call interfaces, and in this folder we'll just create a new interface, class interface, and this interface would be called aggregate root. Now we'll make this interface public, but we won't specify anything in this interface, and this type of interfaces are usually called marker interface. Let's make also marker interface that marks an aggregate root. And of course we can then go back to our user, and of course we say that it also implements aggregate root. We'll also have to add the using statement for that, and then that should be okay. So okay, right now what we want to do is have of course we would need a private constructor, or the constructors that I'll add here, they would be private, and I guess until the end of this current stream we'll also come to understand why I tend to do this. But of course feel free to challenge me if you think that is not a good idea. So it would be a user, we will have a constructor that doesn't really take anything as an input, and it simply would pass to the base, it would pass a new guide, new GUID, and that's it. Sorry, without this here. but okay, this must declare a body because it marks an abstract, extends, or partial. Okay, sorry. Yeah, of course I forgot to add this body, but of course not here. Oh, sorry, I'm a little bit too tired. It's a regular constructor, so yeah, the body comes at the end, of course. And yeah, that should be it. And we'll also use another private constructor. And in this private constructor, let's already build a body so to not have the same problem. In this private constructor, for now, we'll take a GUID ID, and then we call base, and we send the ID to the base. And that should be it. Now, the reason why I also created a private constructor that is empty, or basically I don't do anything is in this constructor, is because when we'll implement entity framework, we'll see that we would need at least a private constructor, a private parameterless constructor, in order for entity framework to work. And this is, well, right, one of the first points where the domain-driven design theory is not something that we can 100% adhere to, because in the domain-driven design theory it says that when you model your domain, you don't have to take into consideration or don't think at all about other layers of the application. But as we'll see, adding entity framework is a very important part of it, and well, this is a workaround to overcome the fact that entity framework really needs an empty constructor, an empty default constructor. So yeah, this is why I have created that one. And the new GUI that we create there basically will never be used, because every time we really create a new user, we'll always also have to provide this GUID, or the ID of that specific user. But now let's go one step further, and we can already start to think about what we need to implement here. Let's also use regions here, because here in user we will have well, a fair amount of code, I would say. And I would say here we have constructors and properties. So we have a region for the constructor and the properties that would end here, I guess. And we'll put all our properties inside of it. Okay, so the first property that we could have, let's say a public string, I don't know, username, get private set. As said, I usually use private setters. Right now, let's also have a property for password. I really don't know if we'll use this property, or maybe if we'll delete it at a later point when we probably implement something like Identity Server 4, but also for testing purposes, until we add support for Identity Server 4, I guess it might be useful to have a password. Also, when we start to really work with passwords at the beginning, we'll just use plain strings. But of course, when we'll go deeper and maybe try to prepare, I would say, the application for deployment, we'll also hash the passwords using also a salt value and so on. But then, if we think about this idea of social network that would be specific for a university, we said that we would have, or we will probably have, different types of user. So we would have probably, I don't know, maybe students, of course, but we would have teachers, and maybe we would have also staff members. And at a later point in this application, each type of user might be able to perform different actions that other types of user are not able to perform according to our domain rules. And for instance, a teacher might be able to, or might have the right or the permissions to create a schedule, but a student shouldn't be able to create a schedule. So in this case, we would have to distinguish between user types. Now, the way we would probably do this, we would have a base user class, and then we will have separate user classes that inherit from that class, but then extend it with specific functionality of that specific user. And the reason why I don't want to do or to go this way right now is because it adds a lot of complexity. And especially when, again, we want to work with Entity Framework Core, this whole inheritance chain will cause a lot of problems. Of course, there are workarounds. Entity Framework Core, well, we have their features that helps us to use with inheritance hierarchies, but still, from my point of view right now, that would add a certain level of complexity. So this would mean that what we would most probably do is, okay, we need a user type. We go ahead and let's create maybe an enum that would be a user type, and we will say here public enum. Of course, we have to delete the class, and then we would say here maybe, I don't know, student, teacher, and stuff for now. Maybe we'll have different other user types. However, the problem that I see with enums is that, well, if you have enums, and let's go back to this type of user right now, and public void, I just create just a method to try to make a point, and let's assume in this method we just get here a user type. Now, and in this method we would maybe do something like this. So we will say switch, and we'll say here type, and then we'll start case type, I don't know, if type case type equals user type dot student, then implement, I don't know, something, whatever, just a console write line, and then I don't know, break. Okay, now sorry. Okay, I guess you get you get the basic idea right now. And what I wanted to show here is that if you have enums, you will probably have in the application at certain points a lot of places where you have logic like this, like switch statements, and then maybe you would have I don't know, default, and on the default you would, I don't know, throw not implemented exception. So the idea is that you would have such a switch statements, and you will go through, okay, different cases, and if none of the cases apply to this specific enum, then we would throw an error as a default. We'll probably catch it, and we'll see further how to handle it. The biggest problem here is that if you at a certain point go here and, I don't know, add a new stuff, and you say here cleaning, because they would have different access levels, you would have to go through all the code base and find all the switch statements for that specific enum and take that new case into consideration, which of course is a very, I would say, very cumbersome things to do. And that's why I usually say that using enums do not respect the open closed principles from the solid principles, because enums are really not open for transformation. Let's say, so we can't simply add behavior without the need to go somewhere else in the code and make changes. And if we can only imagine that we have in our code base 1,000 such switch statements, we would have to find each of the switch statements and then add the necessary logic for this specific enumeration that we just added. So this is why, from my point of view, this is not a very good practice. And what I usually like to do recently is to simply use enumeration classes. And when it comes to enumeration classes, this would be, of course, another base type that we might create. And in this case, let's see how this would work. Of course, since we want to create a new base class right now, this means that what I would like to do here is simply go ahead and implement in the shared kernel, where is the in types, we would have to implement add a new class, and this class would be called enumeration. Since this would be also a base class, of course it would be an abstract one. And from an enumeration, what I would expect as a behavior is that it implements iComparable, so that we can simply compare, but also I would like to implement iEquatable, so that we know when two enumerations are equal. So what we'll have to do right now is basically implement these interfaces. But before we get there, to make this enumeration something similar to what we have in enums, we can have here public int value as a property, get private set, and we have public string description. Let's make it also with a private set. And what we can do, we can implement a constructor, and in this constructor we can simply take in an int value and a string description and assign it to our properties. So that would be it for the value, and description equals description. Okay, that would be it. And then of course what we would need to do is implement equality. Now if you want to implement equality, what we would actually need to do is of course get all the fields of this enumeration and compare them. So this would be basically something similar to what we did for value objects, only that in this case I guess we can use reflection, because each enumeration will have only this value and this description, and those will all be the properties that we actually care about. But then again, I'm not sure exactly if I need this get all right now, because why would we need such a get all method that would return I don't know, maybe the properties or what we have in this enumeration? I guess we don't really need to implement this get all. Of course, when we talk about this type of base class like an enumeration, there is a lot of functionality that you could add to it. But I don't want to add right now functionality that we don't actually need, like following this Yagni principle. So yeah, don't add functionality that we don't need right now. But if we can think about, we can have a get all method that would return all the possible properties of a certain basically each type of the enumeration, like a teacher, a students, a staff, and so on. We would have possibility to check if a certain value exists based on the value, then based on the description. There might be really a lot of things that we could add to such an enumeration class. But I think that really for the base, we just need to implement iEquatable. And let's implement iEquatable in this case. Okay, so yeah, what do we want to do here? So if other equals null, then we want to return false maybe. And then what we want to check for this enumeration is that var type matches. So the two enumerations should be of the same type, and it would be get type for this one, for this enumeration would be equals the get type on other get type. So here we check that that the type matches, and in enums, as it is the case also with the regular enums in C#. The other condition for equality is that value matches, and here it would be okay. We say that the value of the current enumeration equals other.value, and that should be it. And then we have to return a logical operation on those two, and we see that if the type matches and if the value matches, okay, of course I have some typo here. Now it should be okay. So if the type matches and if the value matches, then well, it should be okay. Then what we need to do, as said, best practice is when we are implementing equality, we will public override bool equals, and in this case for the equals we will simply let's say var other value. We'll have to cast this object to an enumeration, and once we do this, we can say that if other value equals null, and in this case other value could equal null if for instance object is not an enumeration. So in that case, of course, we want to return false. That's clear. But otherwise, what we would like to return is simply return equals. So our equals method that we have implemented previously, other value. Okay, good. So we have implemented this one. Then once again, for best practices, implement get hashcode. In this case would be a public override int get hashcode. Get hashcode in this case would be very easy to implement because we just it would be a numeric value, so we can simply say value get hashcode, and this is what we want to return. And also, as a best practice, is to define equality for the operators. So stat public first, public static bool operator equals, and we would have here enumeration left, enumeration right. And here what we can do is something very similar to what we have done also earlier for value objects. And if say if reference equals left null, it's exactly the same logic, left and null, and we want to have an exclusive OR here. Reference equals, this case right null. So in this case we simply return false, and otherwise we return reference equals. Although in this case yeah, but with reference equals we just check if they are null. So in this case we can do that because we don't really bother with the reference itself, only if it is null. And in this case, if it's not null, then we can simply left equals right, and that should be it. And of course we have to also public static bool operator not equal, and that would be very easy to do. We have an enumeration left enumeration right, and we simply have to negate the equals that we would have that we had further. So we would just here return, we would negate and say left equals right. Okay, so that would be it. One other thing that just came into my mind right now, another override that we want to have here is the toString. So public override string, and the toString method, we should simply return the description of the enumeration. In this case, we have we know also how to show this as a string. Okay, so yeah, that would be it, I guess, for the enumeration. Let's go one step further. So once we have implemented this enumeration, we don't have the iComparable. Let's have it. So in this case, the iComparable, I guess it would be simply very easy to implement, and because we just have to compare two numeric values. So we can just say return value dot compare to, and here we want to compare this to the object, but object that is casted to an enumeration object, and we compare it to the value of that object. So that would be it. Something, I think it's not right with the parentheses. Let's this one with this one, and of course we have to have this entire thing, I guess, in, yeah, now it should work. Yeah, now, so we have also implemented this compare to, and with this, I guess that our enumeration base class is done for now. And whenever we might need maybe some more functionality on these enumeration classes, then we could, well, simply go on and add this functionality in the base class. But what I want to do right now is I go back in the domain in social, so in this bounded context, and what I want to do here is this user type, this won't be an enum anymore, it would be a regular class instead. What I mistyped here, so it would be a regular class that of course inherits enumeration. Of course you would have to add this here, and of course we can then implement this just very easily. So what we will need here is a private constructor, and we'll see also why it is private, and we'll have type. What we want to have here is as an incoming parameter is a value, integer that represents a value, and a string that represents the description. And of course we would simply pass this to the base, and here value and description. So this would be it. And right now, to make this really behave like an enum, what is the problem here? Must declare a body. Of course, it's the same thing that we had previously with the body. Of course, it's a constructor, and we need a body. And of course, in this case, we don't need semicolon. Okay, and to make it behave like a real enum that we have in C#, but this would be our custom enum, we could simply use static fields for which we create for each field an instance of user type, and it would be public static. They would be read-only, so nobody should be able to modify them. It would be of type user type, but since these fields right now will be exposed publicly, I would say, for instance, student equals new user type, and I will say here that we have the value 0, and here as a text, as description, we have a student. And of course we can add to our base class also options that we can let's say provide custom values, like we have an enums, and if you don't provide, for instance, a value, you could just start from 0, whatever. But right now I don't think that it's really useful for us to stay a lot more on that enumeration class. I guess we'll simply go back to it every time we find out that we might need to add some new functionality there. Then we have a new user type that would be teacher in this case, and it would, sorry for the typo, and it would be a new user type. In this case we would have one and teacher. And then we have the third type, and it would be stuff equals new user type, and we'll have here 2 and. Another cool thing about this enumeration classes is that you can basically provide here whatever string you want. So if you have worked with enums and at a certain point you might need to use the toString method to show their description, so not their number. Then, for instance, if you have composed words like, I don't know, email address, you would have to write some extension methods for the enum to take that email address and well, break it into 2 separate words, and so on. So it kind of like adds a complexity. But what we could here do is simply add stuff user as the description, and that's it. So we wouldn't have to bother with this type of problems. And when we have our user type, we can go back to our user and say that public, we need a property of type user type. It will be called type, and it will be get and private set. Yeah, that would make it for now. Good. Then the next thing that we would need for this would be a name, I guess, because each user would have a name. However, of course, we are not beginners anymore, and when we think about name, we know that they might have different separate components that are important for, and we won't simply use a string as a name. So the question is, if we need to add a class for the name, what should it be? It should be an entity or a value object. And I'm really curious. I really want to find out your answer. So please write in the chat. If we think about creating a new class for the name, should this new class be an entity or should it be a value object? So please write in the chat. So I'm also writing the question in the chat. Should the name be an entity or a value object? What do you think about it? So if you would have to design right now, if this is your decision right now, would the name be a value object or an entity? Let me drink some more. Again, there's not necessarily a good or a bad answer. For each of the answers, we might have our reasons, but I'm curious also to find out your reasoning about it. So if a name should be a value object or an entity. Okay, I see that you seem to be very, very shy. So then I'll go with my own opinion, and I will enforce it, because, well, I can do that. Is that a name should be a value object, because a name itself is just a value that describes something. So it's not an identity. It's not an entity. It doesn't have to be stored uniquely, because the same name. So for instance, my name, there could be several persons that have the exact same name. But even if the name belongs to different persons, the name itself is the same. So here in this case, I guess we are in a scenario where we need a value object. So let's create a value object. So let's create a new class that we will call name, of course, and this class public class name would inherit from value object. Of course, we would have to add the reference here. And if we think about this name as a value object, first of all, let's we would probably need a constructor, and entity framework would probably also need a parameter this constructor. So we would have a private name, and that's it. But we would also like probably to have a constructor to which we will provide a string first name and string last name, and then we would probably have properties here, public first name, get always private setters. We would have a public string last name, once again with a private setter. But we could also have a property that is called, I don't know, public, that we usually have in applications like this, and it would be initials. And here initially let's say let's set this on a private set. But we can do here is in the constructor we can simply assign here first name equals first name, last name. Here first name should be capitalized because it's the property. Okay, of course I mistyped it, so it would be like this, first name, and last name was last name, and initials is something that we basically can calculate, and we can say here safely first name. We want to go to the first character of this string. We want to transform the character to a string, and then we would like to make it to upper invariant, so to not take care about the culture. And then we could simply add and concatenate it to last name. Once again, we want to get the first character there, make to or call to string on that character, and to upper. Let's make it to upper. So we have also the initials. Now here the idea is about this value objects, and generally in domain driven design. Let's make also here some region, constructor and properties, and let's end the region right now, or right here, and region. The whole idea about these private constructors is that we don't expose the constructors to the outside, but the only thing that we expose to the outside are factory methods. So that from the outside we can statically call a factory method that would create a name for us. And this is a pattern that I really like to implement also in applications where we might not go for the entire domain driven design thing. So what we will do here is I'll have another region would be, which I will call factories. Let's also end it. And then we would have a public static. It would return a name. It would be called create. And right now we'll probably not stick and think about how do we validate first name and last name. We'll come to that at a later point in this application. So we would need here a string first name, a string last name in this factory method, and of course we can then simply return new name and pass in first name. And so yeah, that would be the factory. And now another very thing that or another very important thing about this would be that we would have also to implement a certain type of behavior, like, okay, I want to change my name. Maybe I change my name and I want to reflect this in the social network. And in this case, we'll let's make a new region, which would be public. And if you remember from the theory of domain-driven design, it's actually, or classes or domain models in domain-driven design are more about the behavior, not about the properties. In this case, we have just 3 properties, and we'll add some behavior right now, and we'll probably add a lot of new behavior at a later point in the application. But now from behavior perspective, what we could add here is, okay, we want to change my my name, and we can have a public method that returns a name, and I would say it's change first name. And here we can simply accept a new string that would be represent a new first name. And then again, if you remember from the theory of value objects, is that value objects are immutable. So this means that you can think about them like strings. Strings in C# are actually value objects, and this means that for each time or any time that you actually update a string or add something to the string, what happens behind is that you get basically a totally new string back. You don't actually modify the current string, but you generate a new one. And this is exactly the behavior that, according to the domain-driven design theory, we would also have to implement in our value objects. So this means that if I use this method change first name, so somebody calls this method, okay, I want to change the first name, what I will return here, because the name once created should be immutable, I would simply return a new name. I would new name, but I will pass in here the new first name. Sorry, new. Oh, of course, I did a typo here. So I will pass in the new first name, and I would pass the last name of the current object, because the last name should be still the same. So that's basically it. Right, again, very, very important to notice here why we did this, because according to the theory of domain-driven design, value objects should be immutable. They should not change. If I need to change something about a value object, I simply return a new value object that has the new updated values. And of course, very similar, I could just have another method, public name, that would be called change last name. And in this case, what I can do is simply have a string last name, so a string that represents a last name. And what I can do here is simply return new name, and in this new name I will use the first name, the current first name, so the property, but I will use the last name, but also let's call it new last name to be more explicit that it is the new one. So here I want to add this new last name. So yeah, that's basically it. And now you notice that we still have an error, because guess what? In value objects we have this that abstract method get atomic value. So if we go here and implement it, it simply adds it at the end. This won't be a public method, so I would simply take it out of this region and add it at the end. And it's actually very simple to implement it, because you just need to return an I enumerable back, and you can simply use yield return, and we'll return the first name first. We'll return last name, and maybe if we want to also take the initials into consideration, we can yield return also the initials. But as the initials are basically calculated based on the first name and the last name, I don't think that it is something that we should take into consideration when we want to check for equality. And actually, then that's it. We have a brand new value object that adheres to the principles of domain driven design right now. So I guess we are on track from this perspective. What we can do right now is go back to the user and simply we have a name, get, and private set, and I guess that should be it. Then probably a next thing that we would need to think about is that okay, we would each student maybe belongs to a certain faculty, to a certain department. Each student should belong to a certain class. Each student might have a phone number, an email address. So there are still a lot of things that we would have to define for a user. But I guess this is right now the time to maybe call it a day for now, and we'll return to this user class, to this user entity next time. So this would be next Wednesday, and then we will go on and we'll create some more properties for this user class, and of course we'll add a lot of behavior. We'll add also here factory methods. We'll add here methods to interact or to change. The state of the object. Will also briefly look into invariants and so on. So thank you very much for watching, and I hope I'll see you back here on next Wednesday. So have a good night. Bye.